correct way to do it?
The correct way.
Okay. And I'm not like, that's not a trick. I'm just like making sure we use the time how you want to use it. So we need to solve both of these equations for y. Okay. And that's where I think it could be a little bit of a slowdown for you, because this is a lot of the same stuff we are doing last week. We want to solve each of these equations for y and decide like what is the same or different about them. Okay,
Oh,
so the first thing here is to add 8x to both sides. So it's 7y equals 8x minus 7. Then divide by 7 on both sides. So y equals 8 over 7x minus 1. And then we're going to do the same thing for the second equation. We're going to solve it for y. So we're going to subtract 7x, 4y equals minus 7x plus 8. Divide by 4, divide by 4, divide by 4. Y equals negative 7 over 4x plus 2. Okay. So the first thing you ask yourself is, do these have the same slope?
no.
No. So when they do not have the same slope, there's always one solution. If they have the same slope, there are two possibilities, and that's this, if they have the same slope. Okay. All right. So this one, it's kind of the same as the last one, but they use different wording. So I'll grab another snip here. All right. So let me go ahead and share my screen. All right. So the first one, the first equations are, second equation is already solved for y, so that's good. The second equation, we need to solve it for y. So just like the previous problem, we're going to subtract 8x from both sides. It's always better to put that in the front. So it's minus 7y equals minus 8x minus 7. Then divide by negative 7, divide by negative 7. So y equals 8 over 7x plus 1. Is that okay?
Yeah, so it'd be independent or
All
the
right. So um yeah, the wording here. Um Before we get into that, these are the same slope. Okay, so these are parallel lines.
okay.
Okay,
Mhm.
so that's also part of this. So parallel would be independent, as you said. Dependent is when they are the same line. This one might be one that I just have you do. Could you scroll up to the top, please, so I can see what the question actually asks? Solve the system by graphing. Okay, so you actually have to graph this. Wonderful. All right, let me grab a snip. And I'll probably have to talk you through how to do the graph of it, but let me, all right, let me go ahead and share my screen. Sharing my screen now. All right. So the first equation is ready to graph. Minus 1/2 x plus 4. What is the slope of this equation? Can you tell me what's the slope of this equation?
-1/2.
-1/2. And what's the b value?
4.
4. Now, do you remember, do you start with the slope or the b value?
The slope.
Start with the b value.
Oh.
So you're going to want to go, and it doesn't matter which curve, but you're going to want to grab one of them and go up to 1, 2, 3, 4. You're going to put a dot up there at 4. And then the slope, do you remember what the slope of -1/2 means?
You go down 1 and then 2 to the right.
Down 1 and right 2, down 1, right 2. So you're going to want to get your first line graph as well. You can try that, and then I'll check it here later on. The next thing is to grab the second equation here. Okay, now I think we did this last time where we did what's called the intercept approach, where
Mm-hmm.
we found the intercepts. The reason is because both of those coefficients, the -3 in front of the x and the 3 in front of the y, they both go into the number on the right, is 3,
Yeah.
which means that we're going to do the same thing, or we could solve this for y. Which would you prefer?
Solve for y.
Okay, so I'm going to add 3x to both sides. 3y equals 3x plus 3. I'm going to divide everything by 3. So y equals 1x plus 1. What is the slope of this new line?
Mm, Would it be 1/1?
Yes, the slope is 1/1, perfect, and the b value is 1. Which do you start with, the slope or the b value?
The b value.
Okay, so you start at 1 and you go up 1, right 1, up 1, right 1. And so you should see a graph that looks like that. And it looked like they intersect there at 2, 3. 2, 3. So I'm happy to check uh, on your side if you need me to make sure that graph is correct. I mean, that looks okay to me. I don't know that I guess you'd have to drag that last point where they intersect. Why does it so? Uh, so your point of intersection doesn't look quite right. I don't know if there's a way to zoom in. I mean, I'm looking as close as I can. It doesn't look to me like it's 2, 3. Like it looks to me like you've got to move your point of intersection. Just it's not on the. It doesn't seem. Yeah, it's like you're. Uh, yeah, don't. I wouldn't move that point. See if there's a way to. So you could click on that point and go down 1 and right 2. Yeah, that's fine. Go down 1 and right 2. Okay, that looks okay. I don't know what to say. Um, yeah, I'm not sure. Um, just be as careful as you can with the graphing. We can do another one. Get it.
Okay.
I need a bit of help if you're going to if you could zoom in a little more or restore, go back to the original. I just need the system. Yeah, grab that. All right, go ahead and share my screen. Okay, the first one is ready to graph. Um, the first one, what is the slope of that line? The first one there.
-3/1.
And the B value is -9. So the challenge with graphing here is that you got to go down to -9 to start. 1, 2, 3, 4, 5, 6, 7, 8, 9. You got to go all the way down there to 9. Can you get to that spot at -9 on your graph?
I think so. Yeah, I can.
Okay. Now the issue here is that the slope means you're going to go down 3 and then right 1, which is really hard to do. Like we can at mine because I can just scroll down, but you can also go back the other direction. So you can sort of undo this, which I don't really like doing, but you can go left 1, up 3.
Okay.
So you're going to want to graph these 2 points there. And you're just counting, and you don't count the first one. It's 1, 2, 3. That's the third one there. Is that okay?
Yeah. Mm,
All right. Now for the second one, we got to solve it for y. So we're going to subtract 3x from both sides. So it ends up being 4y equals -3x minus 9. And then we're going to divide by 4. This is not good. Um, are you really graphing these again?
Yeah.
Yeah. So the issue here is that the slope is fine. The slope is -3/4x, but the b value, it's not a nice point. So the other way to do this is, and I don't know how you're supposed to know to do this, but I'm going to pick an x value. I'm going to pick that x is 1, and then you find that y ends up being -3. So we're going to plot that point 1 -3 like that. And then we're going to use this slope here, -3/4, to go down 3 and then right 4.
So I wouldn't start um on the y value at
No, because it's not a nice value. I mean, I don't think your graph can do increments of quarters. So I'm
okay.
suggesting to start at 1 comma -3 and then go the down 3 and the right 4, which I have not done here. It's going to be going over one more. So down 3, right 4. And I'm happy to look over your shoulder on that screen there if that would help
Okay.
to confirm these points. Okay, so that's at -9. So you got to go sort of backwards. You're from that point, you're going to go left 1 and then up 3.
Mm,
Go up 1, 2, 3. There you go. Okay. And the other one, you're going to start at 1, -3. So one -3, not there, not there, not there. That's -3, 1. 1 -3 means to go right 1. So you gotta like imagine start. Yeah, there you go. Right 1 and then down 3. Okay. And you've gone too many.
oh,
Okay. Like, and look, what I can't tell is if it's snapped, like if it's snapped right to the grid or not. I mean, to me, it looks a little bit below,
mhm,
and that might have been the issue with the last one. That looks better to me. And so from that point there, you're going to go down 3 and right 4. Okay. And then the intersection, you can see there's that -3, 0. I don't know, do you have to graph that?
I think so.
Oh, and then it just wanted your answer. So it didn't even, you didn't even actually have to, well, I guess you did. So -3, 0. I wonder if it grades the graph. So I'll need to see all the words at the top there. If you can scroll up to that. Use the graph to solve the system. For each ounce of nuts, he uses twice the amount of raisins. All right, so okay, I gotta grab a snip of this. These are called mixture problems. I don't know. Do you like raisins and nuts?
I don't like nuts, but I like raisins.
I like Raisin Bran. Uh, I've met people that take the raisins out of Raisin Bran, which I think is weird. All right. So there are two types of equations you're going to have. One is called the total equation. Okay. And so for simplicity, I'm going to use X for raisins and Y for nuts. So the total equation is that X plus Y is 24. There's 24 ounces total. Is that okay? How that
Yeah.
reads? All
Mhm.
right. Now, uh, for each ounce of nuts, so nuts is nuts is twice the amount of raisins. I'm sorry, that is not correct. So this one reads weird. So let's just say he has 5 ounces of nuts. He has 10 ounces of raisins. Does that read to you correctly?
Yeah.
So it's either y equals 2x or x equals 2y. This is y and this is x. Which equation is correct? Is it the one on the left or the one on the right?
Mm, one on the right?
Yes. That was why I caught myself and said, oh, that's not right. So, okay. So to graph these, let's go 2y equals x. So to graph these, you want to solve them for y. All right, so we'll do the first equation, x plus y equals 24. Subtract x from both sides. So y equals minus x plus 24. For the second equation, 2y equals x, divide by 2, divide by 2, y equals 1/2 x. All right, so the first equation, you're going to start up at 24, which is going to be really hard for me to show you. So you're going to start up here at 24, and the slope on one means down one, right one. So you're going to want to graph something like that. The other one, the other equation here, you're going to start at 0, and it's got a slope of 1/2. So you're going to go up 1 and right 2, up 1 and right 2. And I'm happy to help you graph those if needed.
Okay.
So let's start with the first one up at 24 on the y-axis. And then you want to go down 1, right 1, down 1, right 1.
For the other equation, would it be 0 and 1?
You start at 0, 0, and then you go up 1 and right 2. No, that's not you're going to want to zoom in on that graph. Your second point on that graph doesn't look to be in the right place. So the slope is 1/2, so it's up 1 and right 2.
Oh.
There it is. Okay. So you have to look and see where they intersect.
Okay.
So you're going to want to zoom and move the graph until you see the intersection point. You may need to zoom in there if you can't exactly see it. Looked like it's, what does it say there? 10 or 16, 16.8. So X from what I wrote, X is the number of raisins. There's 16 raisins, and then there's 16 ounces of raisins. That's the X value. And then the number of nuts is 8. Very good. All right, so for this one, it's about writing the equations. There's going to be a total equation. The total equation is like the x plus y equation. Or I don't
Okay.
know what these have, c plus s. I'll share my screen here in a moment. All right. L is making a pitcher of cafe mocha for each ounce of chocolate syrup. So I guess that's C. Well, actually, I take that back. S is the amount of S is the ounces of chocolate syrup. And C is the number of ounces of coffee. All right, so we know that C plus S equals 48. There's always a total equation. And you want to look for that one first. That gets rid of, so A is out, B is out, but both of these have that relationship. Okay. And so now you have to decide, is it S equals 5C or is it C equals 5S? For each ounce of chocolate syrup, she uses 5 ounces of coffee. So like what I tell students is to make like a quick table. Is it that it's one goes with five or five goes with one? Which is the right understanding of this?
Um, one goes with five.
So there 1 ounce of chocolate syrup, 5 ounces of coffee. So this one. So is it S equals 5C or C equals 5S? And
S
the way the answer is put that one in for S or that five in for C and see if the other one works. Which one works?
S equals 5C.
So that means that when C is five, 5 times 5 is one. Is that correct?
Oh, no.
That's how you do it. That's you say, okay, well, let me put the numbers in. So, does one equals 5 times 5, or does five equal 5 times 1? So you know that this is the correct equation, which means that it is letter E. You have to be able to do this on your own. That's the only way you're going to be successful in this part of the course.
Okay.
Is this the same as the previous one?
I think so.
Okay. Yeah, so we're just going to be solving the equation. So that's good. I mean, this is something you will do in a test. You'll get a couple of story problems like these. Okay, let me go ahead and share my screen. All right. So we already know the equations. We know that C plus S equals 48. And then the second equation was that C equals 5S. So uh the first type of solving systems that you learn after graphing is substitution. Did you guys talk about that at all in class?
Yeah.
All right, so you're going to take this 5S and put it in for C. 5S plus 1S equals 48. So that's 6S equals 48. Divide by 6, divide by 6. What does S equal in this case? What's 48 divided by 6?
8.
8. So that's 8 ounces of syrup. And then C is equal to 5S. So you put that S value in, 5 times 8. So what does C equal?
40.
C equals 40. All right, very good. So is this just a graphing, or do you have to, could you scroll down a little bit so I can see what else is there with the graphing? Okay, scroll up here. All right, so we've done a bunch of these already. So hopefully this all looks super familiar when we do it here. I'm going to share my screen in a moment. All right. So the first thing is that in equation one here, y equals minus 5x over 2 minus 10. What is the slope of this equation?
-5/2.
And what's the b value?
-10.
All right, good. And then the uh, the second equation is if we solve it for x, we get y equals minus x plus 2. What is the slope of this one?
-1/1.
Okay,
And the b value will be 2.
right. Very good. Um, okay, so to graph the first one, the one on the left here, where do you start the graph? Do you start with the slope or the b value?
The b value.
B value. So you go down to minus 10. And then this is where it's going to be hard on your graph. I guess you could, guess I didn't realize your graph zoomed out, but you can go down 5 and then right 2.
Okay.
And then you're going to do the same thing on the other graph. You're going to start at 2. This one is down 1 and right 1.
Okay.
I'm happy to, if you want to share your screen, I'm happy to look at what you're graphing and try to help out. All right. So let's go see where they intersect. Can you go find that point? You have to go up and to the left. And you might want to grab that point of intersection thing.
I don't see where they intersect.
You'll have to move the graph around the top left. You see how they're converging there in the top left?
Yeah.
Yeah, yeah, you'll have to drag. I mean, I can't see what I don't know what tools you have available to you, but I would just move that point of intersection up closer to it and then click and hold the graph to move it around. So like click somewhere in the graph, not on the line, just click somewhere on the graph and then click and then drag down and to the right.
It doesn't let me.
That's interesting. It's really interesting. Uh, okay. I guess I'll check on my side what I see. I've got a graphing tool that I can Uh, pictures one more time. Minus. Okay, so your slope is not correct. You go down to the red one. That's the issue. It's down 5 and then right 2. That's the issue. Like I can't tell that if you've got it or not. Like to me, that looks down 5 and right 1. I'm sorry, that looks down 4 and right 1, not down 5. In the other graph, you were able to zoom sort of and move it around. That's why I'm not
Yeah.
sure what to suggest. But you're that doesn't look to be at the right place. So let's do it this way. Let's go the other direction with the point. So you can go left 2 from negative 10. So go move that point. Yeah, go left 2 and then up 5. You're That's not up 5. That's like up 3. Like each of those major grid lines is a single one. Um, that's not it. That's not it either. So like you got to get up there. There you go. Because when you're going up 5 from -10, there you go. Now that looks good to me. Now the slope on the other one might. And can you zoom in on it at all or not?
Not on the graph.
Okay. So that it's also frustrating. All right. So the other one you're starting at 2, and then you're going down 1 and right 1. It doesn't look like you went right 1 on the blue one.
Oh, okay.
Okay. Now let's. I don't know if that is the. So that your red graph you didn't go left 2. It looks like you went like left 1.5 on it. So you have to go to the left just a tiny bit more. Like I said, I think that's right. So go put that green point where they intersect, which looks like it's -8, 10. Is that the intersection point? -8, 10.
Yeah, I think so.
Okay, and that does work. All right. So it's just a graphing issue.
Yeah.
So on the second one there, what is I'm sorry. So the first one looks good. Yeah, that looks really good. On the red one, what is the slope after you move the -2x over?
Mm, I'm not sure.
Wait, we've done like 3 or 4 examples. Can you move the minus 2x to the other side of the equation? And that will tell you the slope. Is it clear what I'm asking or not?
No.
Okay. Could you scroll up just a little bit? That's sorry, the other direction so I can grab the system. Okay. Now you gotta, one thing you gotta be careful of as well is the red one is supposed to be the graph. So the one you just did in blue is supposed to be the red one. All right. Yeah, so get that one graphed and then I'll share my screen, try to explain what I mean by.
Okay.
So you got to go up 7 and right 2. Good. You got it right there. Perfect. Okay. Let me share my screen. Um, I always recommend taking notes, trying to work out some of these with me, having a notebook out. What I was referring to with the second equation is if you add 2x to both sides, y equals 2x plus 6. And that way you can get the slope. The slope is 2 and the b value is 6. So if you need to, if you want to share your screen again, I'm happy to look at your graph, see if we can get the intersection of these. On the test, you do end up getting one problem where you graph, usually. So you start at 6. And then do you see how that blue equation is minus 2x plus y equals 6, just like you had written
Yeah.
above? And then the red one is the same as the first equation. Like it's telling you that it's correct. Does this one want you to, if you want to scroll down, does it want the intersection point? Nope. You got it then. Good job. Oh, you gotta put that. Yeah, you gotta put that green dot where they intersect. All right, good job. So to determine whether this ordered pair works, you simply substitute the numbers into both equations. So I'm going to grab a snip and I'll show you that here. It has to work in both. So if it doesn't work in one, you know that it doesn't work in both. And that's enough here. So you just start with the first equation, 2x minus 5y equals minus 3. You put that x and y value in. Does 2 times 3 minus 5 times 0, does that equal minus 3? What do you say? Is 2 times 3 minus 5 times 0, does that equal minus 3?
No.
So this is a no. All right, so same thing on this one here. Like that snip, we'll do this real quick. Um, all right, so start with that first equation, minus 2x minus 3y equals minus 3, negative 2 times 2 minus 3 times negative 1/3. Does that equal minus 3? So negative 2 times 2 is negative 4. The negative 3 times negative 1/3 ends up being plus 3 over 3, which is negative 4 plus 1. So that one worked. That one ends up being okay. Do you agree with that?
Yes.
All right. Now let's check the second one because it's got to work in both. It's 2, I'm sorry, is, sorry, get that. Okay. Is negative 1/3, that's for y, x and y. Does that equal negative 3 over 5 times 2 over 1 plus 4? So we've got negative 6 over 5 plus 4. Does that equal negative 1/3? The answer is no. You don't even have to, you can just sort of be like, that's not negative 1/3. So no, it does not work. And they're giving you this problem because they want you to try it in one and be like, oh, it works in one, it probably works in the other. And it's like, nope, no, it does not. Okay. I know that was slow and painful